I'm going to go ahead and ask a question before we get started with this. How many people in here hate databases? Yeah, that's what I like, a semi-hostile crowd. So today we're going to talk about why you probably hate databases, some of the reasons that from a security perspective, a database can be a real problem. Just to give you some background on me, I've started off as a software developer. From that point, I decided I wanted to be an administrator, and then I decided I wanted to be a security consultant. So I did that for a few years, and then I decided that I liked programming more than I liked travel, so programming again. But from my cave, I can continue to do some independent consulting. But I'm not representing my company here, so I don't have a graphics department. I have to use the crappy clip art that comes with PowerPoint, so that's what we have to deal with. So let's get started. Next. All right, the presentation is in 3 sections. The first part is the section I'm going to try to go through as fast as possible. That's the section on SQL Server's built-in security mechanisms, its model, how it works. The reason I try to go over it as fast as possible because it's the most boring part, to be quite honest, and a lot of it's in books online, so if you want more detailed information on it, you can get it there. But I do need to hit the highlights so that the other sections will make more sense. The bad will be a section on the network security portion of SQL Server. How, when it's placed in a network, how are we going to secure this thing, and how should it be placed in the network? How will people attack it from a network security perspective? And the third section will be the most fun part. We'll talk about why poorly written applications can usually bypass all of your good security planning and your high-priced security products. Next. All right, presence. This slide is just, I'm not picking on any particular vendors. I just want to say that this is a fairly ubiquitous application. It shows up all over the place. How many people in here have IDS systems? Network IDS systems? Yeah. If they're based on NT, you may want to take a look and see what's behind it. A lot of times, the database that's actually storing all the information is MSDE, which is SQL Server. Whatever they want to call it, it's nothing really but SQL Server stripped down. Next. Come on. Sorry, Timothy's going to help me out here today. He's my PowerPoint monkey. So
all I have to do is click.
All right. Security framework. Generally, SQL Server security breaks down like this. The SQL Server 2000 model. This is generally the same for all of them. Slightly different for 2000, and some of the names of the tables have changed. But other than that, it's basically you have a client that uses an assorted set of net-libs to connect to the SQL Server and look for an entry in the sysx logins table, the master database. These are what's called logins. In order to get access to the SQL Server, you have to have a login. Once you have that login, you have the capability to access individual databases through the sysusers table. Inside of sysusers table, you have other tables called syspermissions that give you actual permissions to the individual objects inside the database, such as tables, views, store procedures. The important thing to remember is users get assigned the permissions, not the logins. Next. All right, by default, TCP/IP and name pipes are enabled. These are the 2 most popular net-libs that you'll find. The SuperSockets netlib now allows SSL over any network, any netlib, when a trusted certificate is installed on the SQL Server. It used to be, in previous versions, if you wanted to have encryption between a client and a SQL Server, you had to use the multi-protocol RPC mechanism, which is no longer necessary since all of the netlibs now support encryption. It's also be noted that the multi-protocol encryption doesn't support named instances anymore. Named instance in SQL Server gives you the capability to create multiple copies of SQL Server and have them all installed basically on the same machine. A reason you might want to do this, I guess, might be isolation for hosting purposes. If you wanted to have one customer that had a SQL Server and an instance in their name, and then another customer that had a SQL Server instance in their name, that way their syslogins tables wouldn't overlap. You wouldn't have to create them as separate databases within the same SQL Server, but as 2 separate, totally separate instances of SQL Server. Other netlibs include AppleTalk, NWLink, IPX, SPX, and Banyan Vines. a lot of these are probably going to disappear eventually because most of them don't support named instances, which basically tells me that they're probably going to be exterminated before too long. The Microsoft SQL Server service is configured at install time. It's very tempting when you're installing it to just go ahead and pick. They give you the option, it's still there, to choose local system. And then your password problems go away, and you don't have to worry about the rights and all this kind of mess, and it's still there. But don't do that. The reason is because, like any other service, if someone somehow can make this service do something unintended, that's the level of context that they're going to get. Local system is too high of context for people to be having. A better choice is a local user account, right, with minimal rights, including access to, the files, the SQL Server MDF files, and all, there are some certain registry entries they need to have access to. But if you put that user in that location at install time, SQL Server will take care of all that for you. It'll make sure that that user has the rights to run SQL Server. But you need to create that user ahead of time. And unless you have some kind of special requirement, like for replication or something like that, in which case you might need to use a domain user, right? Because you may have a situation where you have to have two servers communicating for a heterogeneous query, or the two servers need to be linked for whatever reason. In that case, you probably end up having to use a domain user. But in most cases, a local user with minimal rights is what you need to be using. All right. SQL Server security modes has two modes. One is mixed. Both SQL Server and Windows Authentication mode logins are allowed access. In other words, you can have the nice name pair that you just provide to SQL Server, and it'll let you in. It doesn't care about NT authentication at all. And the other option is, of course, to use your Windows credential. So what will really happen is it'll store your SID and the sysx logins table, and then when you try to log into the SQL Server, it'll check your SID against the SID that it has in the sysx logins table. If they match, you're logged in. The mixed mode has a problem. If you're going to use the name password pair, you don't have strong authentication controls, right? You don't have password complexity requirements. You don't have lockout thresholds. You don't have any of the really good stuff that you need to enforce good authentication. It's all gone. But it is provided for backward compatibility and for Windows 98 and ME installs, because obviously Windows 98 and ME doesn't support any type of NT authentication, so it has to be there for that. Next. Microsoft, of course, recommends that you use Windows authentication mode. And every book that you read on SQL Server Security will probably say, use Windows authentication mode. This is what we recommend. Main problem is Microsoft can't seem to take its own medicine. It seems like every product that they release uses the mixed mode and uses standard SQL Server Security, does not use the integrated model. If you download any of their reference applications from msdn.microsoft.com/code, you'll see they all use the standard SQL Server security model. Many developers avoid anything that involves having to learn security model reserved for IT personnel, right? Because this means you have to understand how the NT model works, right? You have to understand about trusts and how when I log into this user's context, can I go to this machine? What happens in a web farm, right? When I have got 10 different users and they're all a different anonymous user local to that machine, I have to access a SQL Server on the back end. There's a lot of complexity issues that are involved with using the integrated model, and usually developers just want to bypass that stuff and try to get their requirements done. All right, mode guidelines. Generally, this is what we like to go by. If you're doing Windows security, it's a good fit where the SQL Server is exposed to possible attackers. If it's sitting in your intranet, this is probably a good place it's going to be as exposed as anywhere, right? Or heaven forbid it's connected to the internet. You definitely want to use something stronger than the mixed mode security, right? Because you don't have any way to stop somebody from brute forcing their way in. There's no threshold, there's no intrusion detection mechanism built into SQL Server to tell you that somebody's sitting there all day long trying to guess the SA account password. If you have heavy auditing requirements, it's also a good fit, or granular security requirements. Mixed mode is probably a good fit where the SQL Server is completely isolated and probably just tunneled to a particular host. Shared context is acceptable, or administrative overhead and supporting multiple security models is acceptable. When is that acceptable? I don't know, but it may be in some cases. A need for simple connectivity as cost of weak access control is acceptable. Like I said, why was weak access control acceptable? Maybe only in a case where there's a specific tunnel that's set up for these two hosts to communicate, and you're fairly certain about its security, but good luck. SQL Server logins. They're kept in the sysx logins table. The SIDs of users and groups are stored for Windows authentication logins. 16-byte GUID is generated for the normal SQL Server native logins that we were talking about. The users are stored in individual databases. This users table determines who has access to database objects, can be assigned to various roles, and user privileges can be managed using grant, deny, and revoke statements. All right, the roles fall into several categories. Sysadmins, which is the role that we're talking about, it's the main role. That person can do anything inside a SQL Server. That's the SA account that you often see when you're using standard SQL Security, is the sysadmin. You can also you can add users to your sysx logins tables through Windows authentication and grant them access to the sysadmin role, effectively making them SA as well. All right. C2 level auditing. This is something that's been added for SQL Server 2000. This mode will allow you to do really intensive auditing. If you've ever looked at the SQL Server log as it exists today, it's really just an event log. It tells you things like, somebody did an extended store procedure and they loaded this DLL. Somebody did a backup. Somebody did something and it failed. A replication task failed or something like that. It doesn't tell you really detailed information about what query somebody was running when something failed, or what specifically is occurring on the server at this exact moment. You never really know. It's more like like an NT application log or something like that, just telling you key events. The C2 audit mode will give you the capability to actually log everything that's occurring in a SQL Server. Everything. Connections, disconnections, attempted logins, every query that somebody issues. If you have heavy auditing requirements, this is probably a good fit for you, but you're going to need a big hard drive. I can go ahead and warn you on that one. All right, features that affect security, good and bad. Multiple instancing, could be good, could be bad. Could be good that you're isolating this person's logins from this other company's logins, but it could be bad that all of these logins are existing on the same machine, and if that host is compromised, every person's instance of SQL Server on that host is also compromised. The variant data type. I don't know who thought that was a good idea. Somebody thought it was a good idea. Actually, the variant is a little dangerous because it allows you to fudge the data types a little bit when you're injecting SQL code, which we'll talk about later. The crypto API is now used for all internal encryption, thank goodness, because they used to use some proprietary encryption mechanisms for storing information, which they now stopped using. Delegation is now supported for SQL Server. Updatable federated database servers, which are actually kind of cool. User-defined functions and cascading referential integrity. I can't go into the details of a lot of these things, but it's all well documented in books online. All right, this was the end of the boring, he's regurgitating books online section and just telling us how SQL Server works. But I hope you at least got out of this the key ways that SQL Server allows people to authenticate, and some of the exposures that you can probably already start to see as far as the authentication mechanisms that are being used. All right, now let's talk about how people are going to attack your SQL servers. We'll start off with just some fingerprinting and discovery. How are they going to find them in the first place? How are they going to acquire access? How are they going to try to grab a username password pair or grab some NT context so they can access my data? Privilege escalation. Once they grab some type of context, what are they going to do to try to use that to get a higher level of context? Maybe access the operating system, for example. And potential pitfalls, custom DLLs, some application requirements, and source code disclosure. All right, to start off with, finding a target. I mean, anybody's running IIS is probably a pretty good target, right? I mean, who uses anything but SQL Server if they're already using IIS? I don't know. I guess some people out there run Oracle on NT, but I don't know many of them. A good way to find out, obviously, you know the standard stuff, right? You can do the telnet, you can do the head directive and find out what it is. Go to netcraft, I'd be glad to tell you exactly what they're using. Actually, you'll probably find out right away when you see, .asp on every request. You'll know what you're dealing with. You can dig for hints about the target database usage. Go to Deja News, groups.google.com. I need to update that. They got bought out. But if you go there, you'll still get sent to the right place. It'll just say Google all over the place. But if you go to the discussion boards, you can actually just do a search and say, hey, I'm interested in X company, and I'm interested in SQL, and you'll put it in as search criterion, and you'll see people asking questions, right? People in those companies, somewhere, somehow, they have a problem with SQL Server. So they'll go to the news groups and they'll say, I'm having this problem with this query. It really shouldn't work like this. It should do this other thing. Oh, here's the query, and they'll post the whole thing up there. And then somebody will come back and say, well, you forgot to do this, you forgot to do that. It becomes pretty obvious what kind of databases that they're using inside their operation. On top of that, you can always just go to their site, and if they're hiring, which they probably are, they'll tell you what kind of skills they're looking for. If they're looking for SQL Server skills, there you go. All right, good news. Like I said, I'm not gonna beat this one into the ground, but the gist of this is if you're gonna have people asking questions, have them do it anonymously. They don't have to do it with like the name of the company, so-and-so at .com. They could use a free email address, something like that. They'll still get the answers to their problems, but don't let information about what's going on behind your firewall or so forth kind of leak out, and especially don't let them post source code. That's real bad. All right, how are they going to find it? Well, the easy way, right? They'll just scan looking for 1433. 1433 is the default port. For SQL Server listening on IP sockets, which we already said is the default, you'll find it listing on 1433. Now you can just do a sweep, a scan. Maybe it's in their DMZ. Maybe you're already on the internal network and you just want to sweep around and see who's installed the thing internally. They stick out like a sore thumb. There's also now UDP port 1434, thanks to this multiple instancing that we have. The reason that 1433 is now listening is that it's a little more difficult to connect to a server that has 5 instances of SQL Server and then tell it exactly which instance we're interested in. And that's where the multiple instancing comes in. It has the capability to ask the SQL Server, hey, what's running? What instances of SQL Server are running on this machine? And get that information so they can make the proper connection. For obvious reasons. I have 5 instances of SQL Server. They can't all be listening on 1433, right? The others are listening on something else. So they'll have to ask to find out what those instances are listening on. So here's an example of a simple scan, right? You scan this host, you see 1433. It's pretty self-explanatory. Multiple instancing capabilities of SQL Server 2000 make enumeration a functional requirement. Specially formed UDP packet directed at port 1434 caused the SQL Server 2000 listener service to divulge information about every instance of SQL Server running. Here's some information that's going to be included. Instance names, all of the net-libs that are supported on that machine, TCP ports, and pipe names. So you can change the pipe names if you want to. You think you're being all clever about, well, I'll change the pipe name to something that's not the default, and then they'll never find it. No, they'll find it. Clustering support is, I don't know why you have to know that the server is clustered and why this was important, but they'll tell you whether or not the server is clustered, which makes your really juicy targets stick out even more. Now, since the listener may exist on multiple machines, it's possible to send a broadcast packet to UDP port 1434 to discover all instances of SQL Server 2000 on a subnet. This is actually a lot of fun. If you've got a large, big, flat network, you can send this thing out, and it's unbelievable. You can start out with just using the OSQL-L command. That'll just give you a list of the server names. That's what they give you, right? You don't need any special tools to do that. But they strip out all the good information, and they just send out the packet, and they just strip off all the server names and give those to you. So here's an example of a discovery packet. This was captured using Snort, and it just shows I sent out a packet to the network, or in this case actually directed at a particular host, and he sends back to me this detailed information inside the packet. Server name, instance name, clustered version. The version information is actually very important, right? Because you can look at that version information and tell what patches they've applied. So it's good to know the exact version that you're dealing with. You can tell immediately exactly what the server is vulnerable to. All right, and in lieu of this, the OSQL utility not providing all this information and having to use Snort to do this, which was kind of cumbersome if you have, 1,000 hosts or whatever, and you want to just search through and find out what the SQL servers are. I went ahead and wrote this SQL ping utility to go through, send out the same packet just like OSQL does, but actually take all the responses and decode them so that you can see all of the detailed information. I've posted it up on my site, and the source code's also there just to make sure, if you're really paranoid and you want to make sure I haven't put some kind of Trojan in there, you can just download the source code and compile it yourself. Next. All right, account acquisition. Attacks, the inherent weak, this is the brute force method, right? This is somebody that's just stuck the thing in their DMZ, didn't protect it at all, didn't configure the firewall to block 1433. They have the complete capability to just attack this thing all day long. Or it could be just an attack internally, right? You could have SQL Server installed on your machine, and the guy in the next cube decides he wants to see who you're writing email to, so he wants to try to gain access to your machine, so he can just sit there all day and try to brute force your SA account if you're in the mixed security mode. There's multiple freeware tools to do this. They all do the same thing pretty much. They attack SA. It's an easy target, right? It's always there. You can't get rid of it. You can't rename it. You can't disable it. So if you've installed SQL Server and it's in mixed mode, it's just a matter of time. Like I said, we won't say it again, but it doesn't have all that lockout capability. So, and I always say that I'm never going to say it, but I put the thing on here. Don't leave the SA password null. Just don't do that. Don't do that. Even if you decide to use mixed mode, or not mixed mode, but you decide to use Windows authentication mode, go in and assign an SA password anyway. Nobody can use it, right? But in some point, somehow, if somebody switches the mode back to mixed, you won't immediately be vulnerable. Sniffing, all right? You probably see this slide in every presentation, right? Somebody's always sniffing. If you sniff and you're watching somebody log in to a SQL server via Windows, not Windows, but standard SQL authentication, you will see the name password pair in plain text. I do it with my hand like this because it's not really plain. You can't see it flying across. It's obfuscated. It's XORed, but it's there. Anybody that knows the scheme, and anybody that knows XOR, and that should be everybody in here, knows that you can easily turn it right back into plain text. The TCP traffic, the non-SSL traffic anyways, is pretty much just, it's there for the taking. And you don't even need the credentials, right? You can just watch the data. Maybe you're just interested in the credit card numbers that are flying by or whatever. So there's a lot of information to be had there. Connection strings. This is another one. People always ask me, where do you store the connection string, right? It's always going to end up, somebody's going to grab this thing. So what's a safe place to put it? People tell me don't put it in the global ASA file because as soon as the next IIS source code disclosure of the week comes out, they'll be looking at it and then they can just go right for it. Well, it comes back to this. They shouldn't be able to connect to it in the first place. If they can connect to it in the first place, you got a problem. So hiding the string is kind of redundant. There's really no good place to keep it. What you want to do, and we'll talk about later, is not necessarily hide the connection string so much because you shouldn't be a secret in there. There shouldn't be anything in that connection string that you're trying to hide because it's going to be exposed. It's just a matter of time. And to reiterate the point, these are just a sampling, a snippet of the latest IIS source code disclosures in the past years. Just my little rant. We'll move on past that. All right, privilege escalation. Besides the obvious capabilities of someone that can get into the database and try to munge around with data, let's just say someone gets in and does get an account that has the capability to run XP command shell, which in this case would be SA. It's more common than you think. Almost every developer that I know at some point, sometime, uses SA and then forgets to go back and create an account before deploying the application. If you use SA or you use an account with administrative privileges, That person, when they gain that level of context, has the capability to run XP command shell. You'll see it over and over and over again. This gives them access to the operating system with the level of security context that the SQL Server is running with, right? Which in a lot of cases, sadly, local system. Okay. Let's see. By default, non-sysadmins don't have access to XP command shell, but that doesn't mean that, we want to minimize that this thing is still very, important piece of the security problem. Just keep in mind that they can access, and if they can escalate their privilege to SA, they can access the actual operating system. You can actually create a proxy account under which non-sysadmins can use XP command shell, because maybe there's something that you want them to be able to shell out and run. But at least let them run that with a lower level of privilege than whatever the SQL Server itself is running at. Okay. All right, some other methods. XP reg read, XP reg write. These are extended store procedures. And just for anybody that doesn't know, extended store procedures are basically DLLs that you can plug into SQL Server to add additional functionality. Now, the ones I'm talking about, like XP reg read and XP reg write here, these are included with SQL Server. There's a long list of them, and almost none of them are documented. So it's really dangerous. You can actually poke around in there. You'll see a lot of things that are really great for enumeration as far as extended store procedures. If you have the time, it's worth taking a look at. And just a couple right there that are really trouble are reg read and reg write, because you have the ability to read and write from the registry. That's not good. SPOA create. This is for automation. You can actually start your own automation, so you can fire up ADO or whatever it is that you're interested in automating, and do whatever you want, really. It's like its own programming language. Enumeration functions. And the open row set command, which gives you heterogeneous query capability to actually, within this query, from like I'm just sitting at a particular SQL server, I can issue query against another SQL server. So in a sense, I can use one SQL server as a launching pad for an attack against another SQL server. All right. Extended store procedures have been found to have buffer overflow vulnerabilities. Most of these have been patched, and the reason that I don't take the slide off, because the patches exist. If you're not putting the patches on, then you probably got 100 other problems. The reason this is important, because they didn't really fix anything. What they did was they fixed the underlying DLL problems, but they didn't fix the real problem, which was the fact that these store procedures are kind of wrapped with an API. And that API is still vulnerable. It doesn't do any type of input validation or bounds checking. So if you write your own extended store procedures, you're just as vulnerable. There's nothing in SQL Server that's going to protect your DLLs from buffer overflows. So it's very important that if you write your own extended store procedures, that you are very careful about doing bounds checking, because SQL Server is not going to help you. All right, they're in. Now what? Create backdoor. They can go ahead and create themselves an NT account. This is if they have the capability to run XP command shell. Insert Trojan extended store procedures to capture passwords, data, and events. They can do this depending on the level of context they've got. Maybe they're a DBO. Maybe they just have the capability to actually enter some data manipulation language. They can use TFTP to pull in rootkits if they can actually issue shell commands. You see that one all the time, right? You can read TFTP. It's on every copy of Windows, so it's a great mechanism for pulling in more Trojan code for you to be running on that SQL Server itself. SQL Server makes a good launching pad for attacks against other hosts. It's probably sitting some nice cozy location in the back where other goodies are, right? Let's forget the fact that all of the real good data is probably stored right there in your SQL Server. It's probably just sitting right next to your OLAP server where all your nice decision support system data is sitting. There's all kinds of juicy targets that are usually adjacent to a SQL Server. It makes a really good launching pad for attacks, and that way you can go ahead and install a proxy and make it a proxy for launching more attacks. Obviously, all the attacks will appear that they're coming from your SQL Server. Take your data and make you suffer. Data diddling, which is always fun, right? If it's a competitor, you can go in there and don't do anything. Don't put pictures of naked women on his front page, and don't go in there and tear the data apart so they know what's wrong. Just tweak things around a little bit. Put some zeros and some bad places and delete a few bits here and there. Dangerous stuff. And as usual, the possibilities are limited only by imagination. All right, your defenses. These are just some things that you could do. Basically, what you want to do, what you really want to do, is design your network properly, right? We just had a great presentation on actually setting up a very nice, well-defended, multi-tiered firewall system where you don't put this SQL Server in a place where it is exposed to attack, right? It only should be connecting to one thing, and that's whatever host it is that it's actually providing services to. It shouldn't be just sitting there waiting for all kinds of people to be interacting with it. Protect it. It's a very important piece of your infrastructure. It should be as protected as that backup server that's holding all of your keys for encryption, right? Treat it like that. Protect it. You could, if you want to, create auto-start store procedures to initiate a trace so that you can watch the kinds of things that are occurring on the server. Obviously, this is for advanced logging, right? It's hard to defend or hard to do any type of forensics after an attack if you don't have decent logging in place. So having an auto-start store procedure to initiate a trace is useful. And the fact that you're going to have more detailed information when something suspicious occurs. I've got Profiler here. It's going to be used to input records into an audit log and so forth. The problem with the Profiler is it's very useful, but it's also resource intensive. So if you're using it, you're probably using extra processor. You're using the processor a little more than you should, and it's got a GUI, and that's tearing you apart. So maybe for situations where you're testing an application or you're doing something specific, yeah, I think it would probably be more useful. In fact, I'll show you a really good example of when you want to use Profiler in building your applications. Like I said, I can't say enough that just completely isolate the SQL Server, and under no circumstances should anybody have any direct connectivity to that port that we were talking about, 1433, from the internet or from any untrusted network, or from a trusted network. Why should your internal users have access to it either? Sensible configuration management will help secure SQL Server itself. Take the time to scan your networks, determine what people on the inside and the outside can access, brute force your own systems to be sure password complexity and account policies, if using Windows security, are sufficient. It's very simple to write your own utilities if you wanted to audit SQL Server logins. If you're still using them, if you're still using Windows native SQL Server authentication, it's easy to audit those things. You can brute force them with ease. So have at it. It's something you should be doing at the very least to find out what the level of complexity is. Thanks. All right, now we get to the really good stuff. Yeah, this is where it really gets fun, because people are getting, I don't know, this is my opinion. I think people in some cases are actually starting to get better at setting up decent perimeter networks, putting firewalls in place, having a firewall up front and a firewall behind this and another firewall. Everybody thinks they got a firewall and they're safe, but this type of attack that we're going to talk about bypasses the firewall entirely, because it goes to the very heart of what an application is supposed to be providing. And because of that, you can do all things right. You can follow all the guidelines for good network design. You can buy the best security products available, and you will still be vulnerable to a poorly written application. So, in a sense, we probably could call this section application hacking, because that's what it really is. All right, it's not specific to SQL Server. We're using SQL Server as an example because that's just happens to be my area of expertise. But the same things that we're doing here can be done to Oracle, MySQL, DB2, Sybase. They're all vulnerable to this to some degree. Not using the exact same methods, perhaps, that we're going to use, but the problem is not related to SQL Server per se. The problem is related to bad coding, bad input validation, bad SQL Server command assembly. All right, SQL injection attacks rarely alert IDS systems, which is really good, right? I mean, nowadays you get kind of paranoid. If you want to, just do an audit of somebody, you got to call the ISP, and you get all nervous because you never know when you're going to set off somebody's system and somebody's going to be knocking at your door. There's a lot of paranoia, but you don't have to worry about that too much here. You don't have to go take your laptop down and find a payphone and get a free ISP and do all the kinds of things you have to do to make yourself as anonymous as possible. In a sense, you're using the application like it was supposed to be used, right? You come up, you put your name in, and you go on. There's no IDS system that's looking for odd-looking input. It's looking for odd-looking packets. It's not looking at the layer that we're looking at, which is the application layer. And even better, even if they were, if you're doing a site that's using SSL, it's encrypted anyway, so who cares? It's difficult to track down the areas of exploitation because the only real solution is manual code review. That's just the reality. I'll show you an example where you can try to black box your applications to find these problems, and you can do that. And QA departments should be, your QA departments, if you're producing code, should already be doing this. But the best way is if you got the source code, no excuse. You have all the ability in the world to fix these problems. No amount of OS security, firewalls, patches, patch diligence is going to stop SQL injection. This is simply something that your developers have to do from the start when they start designing the application. It should be the first thing you do before you even start the app, because it's so difficult to remove once the application is already built. These applications, a lot of times, huge. Huge. You could have 99% of the application coded correctly, but that 1% will get you. I promise it'll get you. All right, here's some really bad ASP code. It's bad from a lot of different perspectives, but we want to try to zone in on the really bad part, which is at the bottom. You've got a situation where someone is basically taking input from a form and sticking it directly into the SQL statement. Now, what's the problem here? It's not validated, right? We don't know what this person is entering. It's difficult to validate a string. Like, I don't know what the person's username could be. It could be anything. So how am I going to validate that? And a password, for example, it could be very complex. I may say, you have to have very complex passwords. I want, all kinds of strange symbols and numbers and upper and lowercase letters. So, it's hard to say, hey, is it a number? If it was a number, it would be very easy to validate. All right, so you have a normal login situation where the person shows up. They have the login page. This is a simulated login page. And they type in their username and password. Hopefully, we didn't write the application so that it displays the password while I type it in. But you see what the SQL Server actually sees, right? He sees the select star from users, where username equals quote, single quote, Bob, which is what the user entered, and the password. Everything seems like it's going to be fine. But what happens if somebody types in this? Bob, and then their password, they put a single quote, they put union, select star from users where admin equals 1. Let's just say for this application that the admin, when that flag is set to 1, the person is an administrator. Well, in this case, the SQL Server is just processing. He's parsing this line across, and everything looks good. He sees select star from users where username equals to Bob, and password equals to quote, quote, empty string. So he didn't get anything probably. There's probably nobody with that. But he unions that with another record set, which is select star from users where admin equals 1. So what ended up happening? The person logs in as an administrator, the administrator of the site. All right, a normal usage. Let's just say the search page, we're getting feedback. This is also a good target. The reason that when I'm probing applications for this particular problem that I like to use search pages is because search pages are very friendly about pulling information out of a database and spitting it back at me. So it's an easy target, right? And this is the best situation you can have. I got an application that's waiting for me to give it some input. It's going to take that input and put it into a command that it's going to send to the SQL Server, which is going to process it and then spit all of that data back at me. So this is a great opportunity for you to rip information out of the database that they didn't intend for you to be able to do. So let's try it. Enter a search. So let's say enter a last name, and I'm putting in my single quote. And what I'm doing here is I'm quoting out, right? It was expecting a single quote In fact, what he does, if you went back to that other command that we were showing, we put the single quote in the application, but by putting it here, we're causing SQL Server to close the quote. And then we're going to put more commands, and in this case, maybe we just want the version of SQL Server that's running, so we just say, we have to actually match up the number of parameters. So if it's returning 3 different columns from the database, I have to make sure that I union it with a record set of 3 columns. So that's why I have the 2 empty string columns, and then I said add version, which returns me the version information for the SQL Server. This is just an example. I mean, you could do anything here. You could say, select star from sys users, or step star from sys objects, which is really the better option, right? If I go to sys objects, I can get a list of all of the tables in this database. So if I get a list of all the tables, I can start going after those tables and pulling data out of them. The user table will probably be clearly marked, and the credit card information will probably be in a clearly marked table. So I can start attacking those directly, pulling the information out of those individual databases or individual tables that I'm interested in. All right. So what I have here is a live demonstration. I'm going to basically show you a sample site. I thought about just attacking a site on the internet, just like for fun, since we have internet connectivity. But my lawyer said it probably wouldn't be a good idea. So we'll just, what I did was I downloaded one of Microsoft's reference applications, and that's what we're going to attack. In some cases, I had to admit, I modified it a little bit for the purposes of our application. So this is not a Microsoft bashing session here. We're going to rip on their reference application, but it does use standard SQL Server security. And as a side effect, I'll show you an area. I laughed when I saw this, but there is an area in this reference application that's just real bad. All right, so here's the sample application. I'll come to it. The sample application it was actually called Nile. I just called it Vile, which it turns out actually was registered by someone. So I had to change it a little bit. But what we're going to do is we sit down at the site and everything looks kind of normal. So we're just kind of cruise around and see what we can see. Well, the first thing I see is that they're using frames, right? Because my URL didn't change. But here I can see, if I start flipping around, that they're using an ASP. So I can see that what's happening here is anytime I pick on one of these little topics, I'm changing the subject. So just for fun, we'll right-click on this. We'll open a new window, just because it makes it easier for us to type stuff in right at the URL. And we'll just type a single quote. And you'll see that what's happened here is they actually are doing some input validation, which is a good thing. They're expecting the subject ID to be a number. And in the code, they checked for that, and it wasn't. Now, I'm giving them a little more credit. They did a cint, but they really didn't do any kind of real validation. If they had done real validation, we would have probably got a little more friendly message than this. But the cint in this case did stop us from trying to inject something into the SQL stream, because all I can put in this place is a number. So let's dig a little deeper. And this is where I started laughing, because I wasn't expecting this actually. But if you go to add to shopping cart, if you look at the bottom, you'll see what actually is getting submitted. The price is in there. So if you want a book for a penny, it's real easy to do here. So open this in a new window. And this is a reference application, I might add. You can see here that I have the capability to just add things to the cart at will, change the price of those things if I want to. But let's see if we can try to get something to the SQL Server itself. So what I might try here is, let's see if we can play around with price. Well, we got the same problem, right? In this case, he's doing a CCUR. He's converting it to a currency data type. So we can't do anything with that. So let's back up a minute and go to the author. That's probably a juicy one, right? So we put a single quote in. Single quotes is a real good indicator, right? If you put single quotes in most of these fields, you're probably not going to get a whole lot of false positives. You might get some false negatives because somebody is doing some decent error handling. So you might get a case where the results might have come back and said 0. But in actuality, there was an LADB or SQL Server or ODBC error that's occurring behind the scenes that somebody just skipped over the error, and didn't bother to display to the user like they are in this case. But in this case, we obviously see that they did, and it's telling us there's incorrect syntax in our book. What can we infer from this? Well, we can infer that obviously we've corrupted the SQL string. So this is a good thing. We've let something make its way back to the SQL Server that the SQL Server did not like, and it threw up on it. So let's see if we can tweak it a little more. What I'm going to do now is I'm going to put 2 dashes, and that is a comment, right? So what I'm doing with that comment is I'm telling the SQL Server, whatever comes after this is just a comment. Ignore it. So I can get my SQL statement to stop where my single quote is. Right? I'm going to try to terminate the string, because what's happened is I've put a single quote in, and then it put in, of course the application put in another quote, and that caused the string to be invalidated. So by putting my single quote in and then putting the comment identifiers, I'm going to try to revalidate the string. Okay, good. Now it's revalidated. So now the SQL Server is telling us exactly what it didn't like about the command that we sent it. And what's happening here is that obviously the person is using a store procedure. The store procedure is called add cart item. The store procedure is expecting a parameter called title, which it wasn't supplied that parameter. So the next thing that we can try to do is provide the parameter. So we can put comma title equals, let's just do nothing, right? All right, so it took that. It liked title, but now it's expecting something else. It wants price. So we'll keep it up, right? It wants price, we'll give it price. So we go back, we add another command. Price. Price is probably a number, so let's put that. I already like that. It still wants yet another parameter. It wants quantity. So let's give it what it wants. The reason we're doing this is because we want to actually revalidate the command. We want this command to actually be processed, because once it's processed, and once we know that we can inject code, which we are proving by doing this, we know that we can tack on more code onto the end of the string and have it be executed. This is important, right? If the string is invalidated, I can't execute anything on the SQL Server. It just keeps throwing it back at me. But as soon as I can get it to run, and it's obvious that I can inject code, then the door's wide open. We can run any SQL command that we want. So let's try quantity equals 0. All right, it took it. All right, now you're in business. As soon as you know that, we know how to validate the command. We can run anything that we want here before our comment. So let's put exec master, because the command that the store procedure that I want to run is in the master database. XP command shell, because it's probably the most popular for network hackers, attackers, crackers, whatever you want to call them. And a command. I won't be evil here. Let's just get a directory. Somebody give me a file name so that we can prove that it's not totally bogus and staged and so forth. What's that? Oh, that's actually quite a good one. Let's do it. boot.ini. This is a Windows 98 machine, so don't worry. Nothing will blow. All right. So what we're doing now is we've taken a SQL command that we know is going to be executed, and we've added more SQL, some insidious SQL, to run a command that we want to run. There's no reason that we have to do this particular command, right? We can do anything what we wanted to. There's all kinds of nice, juicy extended store procedures to do mail, do automation. We could take the information that's in those tables and BCP it out to a file so we can download it later. We could be here all day talking about the things you can do, but basically what we're doing is we're running code on a SQL Server. Yes? As far as the XP command shell, or as far as what we're doing here in general? The injecting happens on any of those, any version. Because the problem, once again, isn't related to the SQL Server. It's related to the fact that we're building a string, a command, to give to the SQL Server, which we're given through the application the ability to add code to. So in a sense, you're turning the user into developer, right? Because now I can put my own code and have it running on the SQL Server. It's TSQL, which to some people, they can just write, they can just run transact SQL code. I hear that all the time. So what can they do with transact SQL code? Well, your developers wrote the application. There's obviously a lot you can do with the SQL code, right? You can pull any of this information that's in here out, given necessary rights. And given necessary rights, you can go to the operating system. It makes a really good way for you to just go right to the OS and do whatever you want. So in this case, that's exactly what we're going to do. So we run that command, and it's taking a little longer because SQL Server has to actually load the XP command shell store procedure. And we go here and back up. I'm typing with one hand here, so give me a break. And there's boot.ini. And we don't even look in it. We know it just contains a directory listing from my C drive. And that's it. You can pretty much do whatever you want with this application from this point on. You can have all kinds of fun. Obviously, they're running as SA, right? Because we were able to run XP command shell. Something else, though, that I wanted to show while I have this running is a good way that you can prevent this type of thing is if you have a QA department, and you should, because a lot of people develop applications internally. You need to have them test for this kind of stuff. And it may sound like it's hard to do because putting all these things in the fields and so forth, it's hard to tell whether or not it's actually making it, because sometimes you have really good people that have written good error handling that doesn't throw back up these ugly OLADB error messages and stuff like that. So you don't know whether or not that code is actually making it to the SQL Server. So it's difficult to debug sometimes. What can really help you in this case is actually running Profiler. And Profiler gives you the capability to filter out certain things, right? So let's create a new trace in Profiler, and that with this trace, I'm going to filter out only a piece of text that I'm interested in, and I'll show you that piece of text. It's pretty arbitrary. I use this because personally, I think that this works best for me. I use a Z. A single quote and a Z. All I'm trying to do here is avoid false positives, but I've rarely had any false positives using this. But the idea is this: if I introduce a Z, a single quote and a Z into my application, it shouldn't make it back to the SQL Server looking just like that, right? If I input it into a numeric field, my application should have handled it and said, nope, it wasn't a number. If I put it into a text field, my application should have said, no, a single quote is not a valid character. I'm going to turn it into two single quotes, which is a valid character for SQL Server. If you want to actually represent a single quote in the SQL Server, you have to use two single quotes. So your application should do one of two things: validate numeric input and turn single quotes into double quotes. If it does those things, we shouldn't see this on the back end. So you run the trace. We'll attack a part of the application that does do some decent filtering or some decent validation, which is the search page. And I'll put my Z, single quote Z in. 0 books found. And I go back here. I don't see it. It never made it. And didn't make it back to the SQL Server as a Z, single quote Z. And that's a good thing. Now, if you're a little more adventurous, you can actually have Profiler do all kinds of things. Like Profiler can take anything that it gets and add it to a table, and you could take that table and put a trigger on it, and you could have that trigger fire off an alert. Yes, it sounds like a lot of work, but it's really not. And that way, you would be alerted when somebody gets that Z, single quote Z, and that might be a little more useful than having somebody sitting here watching, the Profiler screen, raising their hand when they finally see it or whatever. But let's go back to our area, our little piece of code that was bad. And we'll open it up in a new window, and we'll put our Z, single quote Z in, and submit it. Get our little nasty message. And better yet, Profiler has now shown us what it captured, the actual SQL that came back to the SQL Server with our Z, single quote Z in it. So now you know an area that's vulnerable. Now, of course, somebody's still got to, walk through the application, put this in every form field, put this in every query string on the URL that they can find, and try to ferret out where the input validation is not taking place. But it's not exactly, the greatest way. It seems like kind of a kludge, but it's free and it works. And maybe someday somebody will write an application to automate the process. But I don't like to pay for things I can do for free. Okay, that's the demonstration. So let's get back to the slides. Any questions about the demonstration? Oh, sure. You could. It's just that there's so many ways that SQL Server can throw the code back at you. You would have to really build like a database of all the different specific error messages that can come up. If you wanted to just look at the nasty piece of code, like you'd always just look for Microsoft OADB provider and that's a good hint that something's gone wrong, right? When you start to see this, the problem is there's no guarantee that I'm actually using the OADB provider for SQL Server, right? I could be using all kinds of drivers. Maybe I'm using the ODBC drivers. Maybe I'm using, maybe I'm not connecting to SQL Server and I'm connecting to some other database. But if you're just looking for somebody using the OADB provider, because there's several providers that you can use, you could search for this, yeah. But each one of them has like their own error messages and stuff. It's a lot of complexity involved there. But I suppose that you could do it. You could do it that way. But keep in mind, once again, it's hard to look for that because some people handle errors. So you won't get this message. You'll get a nice 0 records or couldn't add this item to this cart or something different if they handled it properly. No application that's in production should be giving people error messages like this. This is nuts. Yeah, I wouldn't use this. This is a bad reference application. Bad. Pardon?
Turn off the recording of that.
Oh, okay. All right. Hey, Tim was bringing up a good point too. A lot of people just in IIS they'll just go ahead and turn it off, so you don't get those messages anyway, because that is a switch that you can turn on and off in the metabase. So a lot of people just turn that off to begin with, and you won't get that error message. All right. What's the main problem that we saw with most of these injection samples? Well, poor input validation, right? Nobody was looking to see what I was entering was a number. Well, maybe they did by doing a conversion, but I don't give them credit for that. And putting secrets in ASP code was pretty bad. But once again, not critical because you shouldn't be having secrets in there anyway, right? If you're putting secrets in your code, you got a problem. Poorly typed. SQL Server and ASP not checking data types. They're not. Security context is too high for the needed functionality. Didn't have to run that application as SA. I mean, it's an online bookstore. Come on. All right, some tricks the attackers use. And I used union statements in some of that code and some of the things I showed you earlier. The reason I use union is because I like to get feedback when I'm injecting code. So that's why I like search pages, because search pages give the capability, because you can just put some code in there. It's a record set that's going to be coming back at the IIS server. If I can union some more data onto that record set, I can have it show up in the result set, which is really good. So one of the things you do with the union is you want to make sure you want to short circuit whatever the previous query was, and then have it append your query onto it. The double hyphen comment indicator to block out the rest of the intended SQL. That's just because, well, the application is going to smack that other single quote on the end and basically invalidate whatever code I put in because it's going to cause a syntax error. So putting that comment basically allows me to say, I don't care what the developer was doing. Take my code and just forget whatever he was doing with the rest of the SQL statement. Obviously, the single quote thing is a quick and dirty way. If you didn't want to have anybody do all this, Z single quote Z thing, you could just have somebody go through the application with the ODBC error messages turned on in the IIS metabase, and then just go ahead and flip through the app until they see that nasty message. It'll be a good indicator that something's seriously wrong. Not even from a security perspective, just from an application development perspective. It's crazy to have your whole application die because somebody put a single quote in it, but it's absolutely ubiquitous. You go out on the internet today, find a site that's running ASP and start putting single quotes in. I give you even odds, it's going to have this problem. All right, a lot of things that people can do. A good indication that you've achieved too much access is to actually ping another host using XP command shell. So you might have a listener out there that's waiting for an ICMP message coming from your target. It's a good indication of two things, actually, that you're able to inject your code in the first place, and two, that you've achieved a level of authorization that has the capability to run XP command shell. It's a system administrator role. So it's a real good indication that that machine is about to be done. You can select name from sys_objects where type equals U. This is just one of the first things that I generally do, is because as soon as I can inject code, I want to go after the really juicy stuff. If, let's just say, for example, that the person didn't run the application as SA, ran it as a normal user. Well, that normal user still has to have access to, to some database objects. It may not be the individual tables, but it may be. But if whatever level of access that they have, I can start poking around in sys_objects to see what other objects exist in that database. I want to see store procedures. I want to see views. I want to see tables. I want to see whatever juicy information is also available for me to get at. And sys_objects is the place to look, because based on type, I can come in here and pull the information out. And it doesn't matter. I always have access to sys_objects no matter what level of permission I have. I can insert table name, exec, SP, whatever. So, and what I can do in this case is I can take a store procedure, take its output, and insert it into a table. Why you might want to do that? Well, what if you exec XP command shell and run something? If you want to see that output displayed back to you in a browser, you could do it this way, right? You could have it go run your extended store procedure, your XP command shell, to, let's just say you want to get a list of users, so you might say net user, and take all of the users that you got, put them to a file, and then maybe have them, read, or actually not a file in this case, but put them in a table, and then have that table unioned onto the back of a SQL statement. So that would be an example of why you might want to do that, right? Because there's all kinds of extended store procedures. They produce output. Why not put that output directly in a table and then have it redisplayed to you through the browser? So that way you can actually see the output of the things that you're doing to the operating system. And obviously, getting the version information is always the first thing, right? You want to know what SQL Server you're looking at, because you may have all kinds of things depending on what version they have and what patches they've applied. There's all kinds of problems. You can just go right to Security Focus and do a lookup on the version of SQL Server, the exact version that they're running, and then you can see all of the exploits, and they'll tell you which patches have to be applied for this exploit to work and not work. So some versions of SQL Server have privilege escalation problems, right? So maybe you have this user with a really low level of privilege. Well, they just go in there and find out what version you're running, boop, go in the Security Focus, find out that you're running an unpatched version of SQL Server 7, boom, find out an exploit that gives them a privilege escalation, and boom, they're off. The new SQL variant data type is really fun if you're fond of unioning, because it used to be kind of an annoyance to union, and you had to get not only the number of columns matched up, but the actual data types. I mean, you could be there all day trying to match up data types. The SQL variant really helped from an attacker's perspective, because you don't have to worry about that anymore. I can take a number, union it with a varchar or whatever data type that I'm interested in, and it'll put those two together in the union statement. It doesn't care anymore, because it'll put a union, it'll put a variant with any other data type. So the result, attackers spend less time guessing about column order. Made it easier to do this kind of stuff. Here's an example, in case you're interested. Just a simple select statement, job level and F name for employee. We did a union, and the thing blows up because the varchar column is not the same type as the integer that we were expecting as a job level. But by just making this simple change and putting these convert SQL variants in on my injected SQL solves the problem. All right, solutions to some of this stuff. Scrub input data to make sure it contains only acceptable characters, right? Replace single quotes with 2 single quotes. And if you use, we'll get on to something like this later, but there's another way that you can do that same thing. The reason that this works, but it's just so hard to do, because an application may have thousands of locations where user input is eventually sent to an SQL statement, right? So tracking them all down is a pretty gargantuan task, but you can do it this way. You can use regular expressions, which are always good if you're going to do input validation, right? Do some regular expression checking. If the person is supposed to be entering, A through Z, and maybe some numbers in a field, then make sure that that's what they've done. So you can use regular expressions for that. And even if you're using VB, yeah, you have access to regular expressions, so you've got no excuse. All right, it helps, but is it 100% effective? Well, not exactly, because you still have the problem of you don't need single quotes to inject code, right? You could have a numeric field where the application is expecting a number, and you didn't validate that the person put in a number. This is what I'm talking about, is the single quote stuff, right? So I do the replace, and it doesn't do me any good because I don't need to put single quotes in the application in order to inject my code, because the person here didn't validate that X was actually a number in the first place. Does that make sense? Yes? No? Okay. This is blank stares. Store procedures can help enforce stronger typing, but using them at every database access can be brutal due to the sheer number of procs that may be needed. I don't care if it's brutal. You should be doing it anyway. The reason store procedures are good is because they abstract access. They allow you to do things like let a person input a record into this table. Let a person select some records out of that table. Let a person update a record, but not give them access to the table at all. If you create a store procedure and you don't break a trust chain, which you can look up in books online, we won't get into that, but if you create a store procedure and all the database objects are owned by DBO, then what will happen is when a person runs that store procedure, all they have to have is execute rights to run the procedure, but they don't need rights for the underlying objects inside that store procedure. Now, why is this good? Because if this had been done, I wouldn't be able to do things like select from other tables and pull information out of those other tables, like a credit card table, for example, right? If I'm able to inject code, my application probably doesn't give me the capability to actually read back the credit card numbers. It probably just stores them, and some back-end system uses them to do reconciliation. So giving me execute access to the store procedures then is something that obviously has to happen for the application to run, but you don't have to give me access to the individual tables so that I can't go once I'm in and start looking around inside of those tables, because I don't have select access to them. I don't have insert, update, delete access to any of the tables inside of the application itself. That's why store procedures are really useful. Okay, you can still poorly implement them, right? You can do that same stupid string building method for doing database access that causes the same exact problems even with a store procedure. So in this case, we got somebody that's trying to run a store procedure, but they're using the same kind of thing. Now, let's just say we did inject some code here. If they did this to the entire application, the only advantage is the only thing that this person is going to do in this application is be able to run more store procedures. And if I've properly written the application, that may not be such a bad thing. Maybe they can select something. Maybe they can insert something. But certainly it's not. Yeah, show me everything that's in the credit card table. Show me everything that's in the user table. I mean, you control the access. That's the advantage. You control what people do to the application through these store procedures. A better implementation of the store procedure is to actually make use of the ADO objects, specifically the command object, because what this allows you to do is create the parameters explicitly, and you can assign them data types. So you get like a 2-for-1 here. You're actually getting data typing, which is good, and you're getting the actual added benefit that ADO will automatically convert your single quotes into double quotes, which is very nice. This is a good way to do it from a lot of perspectives, not the least of which is that if you centralize this and you make every developer use a centralized data access routine that makes use of the ADO intrinsic objects such as connection, command, record set, etc., you don't have to go through 1,000 different ASP pages to find and get these problems fixed. And that's about as close to hell as you ever want to be, is trying to fix an ASP app with 500 pages and everybody's accessing the database in a different way. There's also a little hidden method for actually running store procedures. Is that if you just create an instance of the connection object, you can just do a dot and expose the store procedures like they're a method of the command object or the connection object, which is actually kind of cool. And it does the same stuff behind the scenes, so it'll turn your single quotes into double quotes as well. Discipline. Make sure developers adhere to the standards. Develop a methodology. Like I said, you got to do this stuff up front. It's just too hard to do at the end of a development project. Whether you're using ASP, PHP, JSP, I don't care. You just have to sit down ahead of time and go ahead and develop a coherent and unified strategy for database access. Don't let everybody do something different, because if you have a problem later, it'll be impossible to fix. No access to production servers. Keep developers off production systems. I don't think anybody here is going to argue with that. Consistent database access and developer education. You know, developers, they're kind of like the last people who seem to know anything about security. I don't know why. You have IT people, right? You have the security people who are kind of in with the IT people. They're kind of kept separate. And the developers are like these people you lock in the back room. Those people should know about security, because they can be just as much a contributor to the compromise of your systems as a bad security administrator or a bad firewall administrator, right? They're just working on a different layer. But that layer can bring you down just as much as, you know, a layer 3 exploit. All right, encourage reusable security components, code review, QA test plans. You know, it sounds so boring, you know, QA test plans. That's the best thing that you can do. It's the best thing. Actually test the application. You know, you've got every opportunity. You have the source code. You can fix this stuff. And, you know, code with this kind of mindset that you're already attacking it. You know, when I'm writing code, all I can think about is what can I do to break this? And you should be doing the same thing, and encouraging your developers to do it as well. Use the principle of least privilege, right? It sticks out like a sore thumb. It's something you're going to see at every level. You want to use the principle of least privilege when you install SQL Server. You want to use the principle of least privilege when you give people developmental access. You want to use the principle of least privilege when you actually run the application, right? The application should never run as SA. It should run with some lowly user that only exists in this database, that only has access to store procedures that you created. Take the time to properly implement trusted security, integrated mode. The reason I say this is because you just remove that whole SQL security model. It's ugly, it's hideous. Take the time to use integrated security. It's not that difficult. If you really just understand how the thing works, it's not that hard to give whatever user context the IAS server is using for an anonymous users, and give it access to the database. It sounds insidious. You're giving anonymous users access to the database. Well, they already have access to the database. You know, if you create a connection string and you put embed, you know, username, password in there, you've given them access to the database. It's the same thing. The important part is that with integrated security, there's no secret sitting in the connection string anymore. It just says, you know, trusted security equals yes. No secret there. It actually eases. It's more of a help in administration later on, I got to say that, because now you don't have to go and rotate passwords. So you have somebody that come in and say, well, we got to rotate our SQL security passwords every 2 weeks. So every 2 weeks you're going through every application, fixing connection strings, goes away. All right, don't place passwords in scripted code. Don't assign complex SA password even when using integrated security. And consider dropping certain procedures in the interest of security, namely XP command shell, right? Because you can drop extended store procedures. A good attacker will just add it back. But, you know, it's one of those things. Can somebody steal your car if you lock it? Yeah. So why do you lock your car? Well, you lock your car because it stops probably 90% of the people out there. That's why you do it. Write reusable input validation routines and make their use mandatory. Use store procedures where possible. Avoid string building for executing them. Code reviews, absolutely necessary. Evaluate third-party code and applications with great scrutiny, right? Somebody's going to incorporate a component in your application, or they're going to add some new pages to your system. Make sure you look at them. Make sure they're not doing something really stupid. Use the same kind of methods we've just shown to go exactly and look at their applications before they integrate them with yours and bring you down with them. Use SSL or IPsec to encrypt network traffic on suspect subnets. Everybody always says, well, doesn't that degrade performance? Yes, it does. So, just a matter of what's important to you. Best practices, minimize risk. Assume your connection strings are compromised, right? Just assume it. It'll happen. If you put a connection string in ASP, you put it in global ASA. If you're using .NET, it'll be in web.config. And they move this stuff around, but it's all the same thing. It'll eventually be exposed. Deny access to all the tables, just like we were talking about. Use store procedures and views to force access only through your own database constructs. Consider using asymmetric encryption on valuable data. The reason I say this, a lot of people will say, well, we've encrypted all of the information, all of the credit card information on our servers, so it's safe. Well, is it? Like, where's the key, right? If you use symmetric encryption, the key's probably sitting on the same machine. So if the machine is compromised, the key is compromised, your data is compromised. One thing that you may want to try is asymmetric encryption. This makes things a little more complex, right? You gotta create a public-private key pair. You have to use the public key to encrypt the data that's actually stored in the side of the database, and then you have some other back-end system with a private key that then decrypts the information for the purposes of reconciliation. More complex, but this way, if the SQL server is compromised, the IIS server is compromised, the data is not compromised. And egress filtering, right? You might want to say, why should a SQL server be making outgoing connections anywhere? Why? There should be no reasons. If it's sitting in some back corner, some cubbyhole somewhere, it shouldn't be initiating connections back out. So it shouldn't be trying to FTP things in, or be trying to connect to other machines inside the back end somewhere, unless of course you have linked servers or something like that. But you know how to configure these things so that you can kind of contain some of the malicious activity. And never place administrative pages on the same server with a normal website code, or administrative store procedures in the same database with normal procedures. And this should be obvious to you. If I give that user the right to run store procedures, they shouldn't have the really juicy store procedures right there in the same database, right? The juicy store procedures for administration should be somewhere else entirely. And never place the administrative pages. I mean, that's just obvious. Best practices integrity. SQL Demo has a method for database objects to script the entire database. So at some point later on, you could use something like this to create your own tripwire system, for example. Script out the entire database, and then tomorrow script out the entire database. Are the two scripts the same? No? Uh-oh. Web services. We're starting talking about .NET a little bit. I've been doing a lot of .NET development lately, so I just wanted to make a few comments about that. Actually, the web services, in my opinion, don't have anything really to do with .NET. It's the marketing stuff. But web services you can do anywhere, anyhow, right? But the point is that no matter how you implement them, they're probably front-ending database operations. So there's no reason, and I've already shown that you can do SQL injection through web services. So watch out for that. So the .NET framework also provides input validation, encryption, and session management function. Use them. Most of the same, all the attacks that we've shown here today can be done in .NET. It's not going to protect you from any of this stuff. But what it does do, what .NET does give you is some reusable components that help this, right? They give you things like validation controls and so forth that make it a lot easier to do input validation. You don't have to go and write, a gazillion, regular expression functions and all this kind of mess. But they help you out, but you're still going to have to work at this. Technology goes on, but bad coding is eternal. I mean, you can still make your application so bad that, yes, not even .NET's going to save you. And here are some reference links, just if you want to find some more information about SQL Server security, and how to break it, basically. Recommended reading. These are just some books I like. Everybody probably has their own. I basically give RFP credit for getting me started in SQL Server security, specifically because of his FRAC article. It was very good, and that's what started me down this track, so I want to give him credit for that. And that's basically it. That's my presentation. So if there's any questions, that's it. We'll see you at lunch.
This was the finger.